You. First one, the food truck offers tacos with 3 choices of meat, 2 types of salsa, and 2 sizes, small and large. If we're using our counting principle, we have 3 choices of meat, 2 choices of salsa, and 2 sizes. And when we multiply all those out, we get 10 possible combinations. You can also do this using a tree diagram, drawing it out, chicken, beef, and tofu. And then within that, I have mild and spicy for each one. And then again, you can branch out, drawing all these little branches. Like it's good. Have a small and a large for each of these, resulting again in 12 outcomes. So if we're looking at what is the probability that a randomly ordered taco is large, I can look at all of my large options, in which I have 6/12, which is 1/2. What is the probability the meat is chicken? If I were to look at this whole branch, I have 4 out of 12 options, which we can also say is 1 out of 3rd. And what is the probability that it is a beef taco with spicy salsa? So I'm going to go highlight this in blue. I have a beef taco with spicy salsa, and I have 2 options there. So I have 2 out of 12 or 1/6. All right, a store sells jackets at 6 colors, 4 designs, and 3 sizes. You can use on multiplication to do this. So we have 72 possible jacket opportunities. How many 8-digit telephone numbers? If the first digit must be 3 and the last 2 digits must be 0, I'm going to use the slot method. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to make that look a little bit nicer. 1 second. So I have 1, 2, 3, 4, 5, 6, 7, 8. If I know that the first digit must be a 3, that means there's only 1 option there. My last 2 digits must be 0. So those also give me 1 option. I have 10 different individual numbers that I can fill into these slots. And then I need to multiply all the way across. By doing all that multiplication, I end up with 1 million options of phone numbers. All right, moving on to number 4. There are 18 runners in a race. How many ways can first, second, and third place be awarded? We have to decide, is this a combination or a permutation? In this case, we have a permutation because the order matters. So I have 18 possible runners. Permutation 3, which we can put directly into our calculator. Like so. Now for our next one, 11 students are in line. How many different groups of 4 can be chosen? Again, the order does not matter for this one. So I'm going to have a combination of 11 choose 4, which goes to 330. Now, if you forgot how to put this into your calculator, I'm going to show 4 and 5. Let me switch over. The online calculator is not working. So I'm going to put the steps in a different video for y'all. All right, next part of the review. All right, another license plate problem. A license plate has 2 letters followed by 4 digits, 2 letters, 4 digits. How many plates are possible if repetition is allowed? So I have 26, and 26 can go in my first slots. 10, 10, 10, 10. in my next. Multiplying straight across, and we get 6, 7, 6, 1, 2, 3, 4. Yeah. I'm going to zoom in a little bit, give us more space. There we go. All right, how many if no repetitions are allowed? We still have our 6 slots. But now I have 26 letters. If we're not allowed to repeat letters, my next let goes to 25. Now I'm switching to numbers. 10, 9, 8, 7. And we're multiplying in between these to get an answer of 3276000. Remember, when repetitions are allowed, it's going to end with more results. All right, a password must contain 5 letters chosen from A, B, C, D, E, F, G. No repetition is allowed. How many different passwords are possible? So I have 1, 2, 3, 4, 5 opportunities. I have a total of 7 letters. So I have 7, 6, 5, 4, 3. Multiplying this out, and we have a possibility of 2,520 passwords. Now for number 8, I want you to try this on your own. It is identical to our first problem, just with apple juice instead, or juice toppings instead of types of meat. All right, jump into number 9. Okay, a sandwich shop offers 2 breads, wheat and rye, 3 fillings, and 2 condiments. Using the counting principle, we want to find the different sandwich combinations. So again, I'm going to use my counting principle to do 2 times 3 times 2, which again gives me 12 possibilities. Now when I'm creating my tree diagram, it's a little bit different because we start off with 2 options of wheat or rye. Then we have 3 fillings, 1, 2, 3, 1, 2, 3, of turkey, ham, or veggie. And then from there, we have, you can only choose one. Mustard, I'm going to put mayo with a Y. Ah, sorry. Sorry, my pen keeps going. I'm going to move all of these over here. Just to give myself more space. All right, now determining what our probabilities were. What's the probability a sandwich has turkey? Well, I have these possibilities and I have these possibilities. So a total of 1, 2, 3, 4 out of 12, or 1/3. Go to green for the next one. What's the probability that a sandwich has wheat bread and mustard? So if I look at here, I go wheat bread mustard, wheat bread mustard, wheat bread mustard. So we have 3 out of our 12 possibilities, or 1 out of 4. And then what is the probability that a sandwich is a veggie sandwich with mayo? Well, I could have wheat bread, veggie, mayo. That's one option. I could have rye, veggie, and mayo. So 2 out of 12, which simplifies to 1/6. Okay, coming on down. A smoothie company has 4 fruit options, 2 liquid bases, and a choice of yes or no for protein powder. So I have 4 times 2 times 2, which gives me 16 total possible options. Drawing out this tree diagram, I'm just going to use fruits 1, 2, 3, and 4. I'm going to put, well, you know what? I'll label them as orange, apple, grape, and lemon. for my fruit options, and then my bases, water or milk, and then yes or no, okay? So drawing my tree diagram, I'm gonna start with my 4 fruits. I have orange, apple, grape, and lemon. Then for each of these, I have 2 options. So I could have water or milk. And then based on all those options, I could have yes or no for protein powder. Okay, now what I want you to notice is as we're counting, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 options of yes or no, which matches up with our total possible smoothie combinations. So if we wanted to find probabilities of this, we would be able to use our base number of 16 for our denominator. All right, for number 11, I'm actually not going to draw a tree diagram for this, because it gets very crazy with all 24 pieces. So our counting principle tells us 6 die times 4, which gives me 24. Instead of drawing this tree diagram, I want to remind you that we can also draw out a sample space, meaning our list of all possible items, which our tree diagrams do provide, but sometimes it's easier to write it out like this. So I could roll a 1, 2, 3, 4, 5, or 6, and it could be all of those could land on red. I could also have 1, 2, 3, 4, 5, and 6, and all of them could land on blue. And we can do this with our green and our yellow. To give us our 24 possible outcomes. This is just a different way that you could write it out. So the probability of rolling a 3, I'm going to look at everywhere that has a 3, and I have 4 out of 24. I'm filming a video. Can you come back in like 10 minutes? Sorry, some people came to the door. Oh, which doesn't result in 1 out of 24, it results in 1 out of 6. All right, the probability of landing on blue, which I should have done in blue, but we're just going to mix it up. I have all of these options, which is 6 out of 24, which would result in 1 out of 4. And then finally, the probability of rolling a 5 and spinning a green. So 5 green, we only have 1 option of this. So I have 1 out of 24. Okay. All righty. Now, the next problem, there's a lot of typos. So if you had done this one, it's okay. 3 main dishes, 2 sides, 2 drinks. We're going to just come talk to your teacher because we don't know what the dishes were. If we're making up a sandwich, wrap fries and a soda, just come talk to us about that one. All right. But good luck on your quiz. Please come see us at lunch if you have any additional questions.